All right, so today we are learning about rational expressions. This is the first page of the Chapter 8 packet. I'm going to sort of be giving you the PDFs as we go along. If you picked up the packet from school that week that we're not in school, but you were able to come back like Monday, Tuesday, Wednesday, and you picked up the packet, you can follow along. This is just the first page. But anyway, we're going to start with rational expressions. So a rational expression, let's get the whole definition on there. There we go. The rational expression is a quotient of two polynomial expressions. So if we're trying to simplify, there are some things we need to look for. So if we have a rational expression, we're going to try to factor everything that can be factored, simplify the monomials, okay, remember your exponent rules, and then we're going to eliminate common binomial factors. So for the first one, we have two monomials, okay, we have, again, one term up here, one term right here. So if we're looking, we say to ourselves, let's zoom in here. All right, we're going to say, what's 20 divided by 14? So instead of putting it in a calculator or putting it as a decimal, I'm just going to say, okay, they're both even numbers. So if I divide both of them by 2, I get 10 over 7. And that's actually the most it can be reduced, and that's what I'm going to leave it as. Then I say to myself, okay, I have x to the 6th and x to the 2nd. So if we remember our exponent rules, okay, let's try and remember what that is. If we forget, let's pause. Okay, what x to the 6th divided by x to the 2nd is. If you forget your exponent rules, you can always do this. I know it takes a little bit of time, but it will help you remember, hopefully, what your exponent rules are. X divided by x and x divided by x would turn into a 1. So what would you be left with? 1 times 1 times x times x times x times x. So you'd be left with x to the 4th, okay? Now, hopefully, you're saying to yourself, oh, yeah, I remember. You just do 6 minus 2. Okay, you subtract the exponents to get your answer, which is x to the 4th, okay? And seeing as how it's x to the 4th on the top, okay, that would go up there, okay? And that's number 1. All right, number 2. I'm saying to myself, okay, let's try and look at this and let's factor everything that can be factored, because now, okay, I don't have monomials like in the first question. I have 2 terms, which makes it a binomial on the numerator. And same thing's happening in the denominator. I have 2 terms, so it's a binomial in the denominator as well. So because of this, okay, you can't just say to yourself, oh, this 6 and this 6 is going to cancel out. That's not true. If we remember from class, if you had this, okay, 1 plus 3 is obviously 4, 2 plus 3 is obviously 5. Well, if you said that you could cancel out 6 and the 6, well, you'd probably think, oh, we can cancel out the 3's. And what would we get? We would get 1 over 2. Obviously, 1 over 2 is not the same as 4 over 5. So you are not allowed to cross out the 6's. You're not allowed to cross out the 3's, okay? So what we have, let me pause the video for a second. All right, so what we have to do is look for a GCF. So up in the numerator, you see 6k minus 36. A GCF would be 6. If I factor out that GCF, I get k minus 6 over k minus 6. So now I'm hoping you see k minus 6 in the top, k minus 6 in the bottom. And if you're saying to yourself, wait a second, I thought you said we just can't cancel some stuff out. The reason why this is a little different is because if we use the same example, but instead of addition, we use multiplication. Okay, 1 times 3 would be 3, 2 times 3 would be 6. Okay, is that the same thing if we cancel out the 3's? Yeah, it's 1/2. So what happens is that if there's multiplication going on in between terms, you can actually cross out, and you would be okay. All right. So if you're crossing out, you just want to make sure there's multiplication going on in between the two terms. There we go. Multiplication going on in between the two terms before you cancel them out. Okay. Next, for number 4, I'm saying to myself, okay, I need to factor out a GCF. So up top, they all are divisible by 2. On the bottom, they are divisible by 8. Okay, so the next thing I see is I have a trinomial right here, which means I'm going to factor. And hopefully after the last couple days of factoring, we remember, oh, I have a of 1. So all I have to do is figure out what are my factors of c that add up to b. So my factors of negative 20 that add up to negative 1 would be negative 5 and 4. Again, negative 5 and a positive 4. And on the bottom, I have I have 8 r plus 4. Okay. Again, because there's multiplication going on in between these terms, I can cross out the r plus 4s. And I can also cross out the 2 and the 8 because they are both even numbers. Right, so I can, if you just had 2 over 8 in general, you could have crossed it out and made it a 1/4. So I'm doing that in this problem. So I would get my final answer, r minus 5. Okay, times 1, but that just means it's r minus 5 up top. And then we have a 4 on the bottom. That is my answer for number 4. All right, last one we're going to go over is number 5. If you've noticed on these, like when you're factoring, one of the hints that I'm hoping that you're seeing, if you're kind of going along and doing number 3 as well, is that when you factor, something should cancel out, okay? Especially in the early on stages of this lesson. And on the homework, something should cancel out. So if you factor and something's not canceling out, just try to go back and see if you're maybe factoring wrong. Okay, so for number 5, I see 2 terms. Okay, and then 2 terms. So I'm going to try to factor out a GCF. Unfortunately, there is no GCF on the bottom. There's no GCF up top. I can't factor like we've been doing with the trinomials, but if you remember from 2 days ago, up top, what I have is a square and a square and subtraction. So this is difference of squares. So hopefully you remember how to do that. Hopefully you did your homework on your own. You get p plus 7, p minus 7 up top. And on the bottom you have 7 minus p. So you might be saying to yourself, oh, wait a second. I have p minus 7 and 7 minus p. So you can cancel it out. However, and one of the things that they have over here where it says watch out, when you're canceling 2 things, you got to be careful of the order, okay? Addition, order doesn't really matter, okay, but subtraction, it does. Let's just say, let's put some number in for p. Let's just put a 1 in for p. Okay, so instead of a p here and a p here, let's just put a 1 in for those p's. What would that give us? That would give us negative 6 over 6. What would that reduce to? It'd be a negative 1. And that's actually true of any terms where it's a minus b and b minus a. It's actually always going to give you a negative 1. If you don't believe me, you can try some numbers out for a and b. For right now, I'm just going to let's pick 3, and let's pick for b, let's pick 11. Okay, what's 3 minus 11 over 11 minus 3? That would be negative 8 over 8, which would be negative 1. Okay, so when we cancel out p minus 7 and 7 minus p, we would just be left with a negative 1, not a positive 1. So my final answer would be -1 times p plus 7. Okay, you could leave your answer like that, or you could say -p minus 7 if you distributed the negative in there. Okay, and that would be your answer for number 5. So try 2, 4, and 6 on page 3 that I put on Google Classroom. Use this video, and then if you want more help, I can Zoom tomorrow at 1:30. Okay, good luck.